Hello. Uh, this isn't even a joke. I forgot to change the category to this is gonna be an educational stream. Yes, yes, educational with this thumbnail. I'm committed to doing my homework live because yeah, I oh my god, is that who I think it is? Completely epic. How you doing, homie? Oh my gosh. So where is it? Yeah, hi, hello, hi. Let me get my gamer glasses on so I don't destroy my vision even worse, so I can finally practice my calculus and potentially make fun of myself. Ready to watch me do homework? Now this is prime. Oh fuck me! 1 minute. My fucking desk. I got a standing desk not too long ago because listen, I spend a lot of time on my computer. I cannot destroy my back by just sitting down all the time. Doing good. You ready to watch me do homework? Hell fucking yeah. Yeah, hope you like integrals. Oh my gosh. 1 minute. Let me set the mood. As in, I'm gonna put wrong one. This is not it. Stop it. Stop. Why is everything just went wrong? It's putting what? That was a synthwave boy. Is that what the lo-fi hip hop thing call it now? What the fuck? Why is the YouTube breaking on me? Just give me a moment. Ah, yes. Perfect. Perfect. Alright. Yeah. So I need to like make sure I get my questions up so I don't accidentally fucking like dox myself like a dummy. Alright, let's see. Okay. Oh shit, the page is reset. Yeah, I'm gonna be going over improper integrals and what else? and series. And we're going to determine whether they're divergent or convergent. Divergent or convergent. I can speak, unbelievably. I have a test. Wow, she added a lot of homework. Teach us, me. I got you. I don't even know, like, I just asked my viewers literally today. It's like, hey, I'm just gonna do, like, calculus live. And they're like, fuck it, sure. And now here I am. Alright, let me just get the page. And that is page... what was it? Something around there? Yeah, okay, that's right. Alright, so... it's gonna be a bit hard for me to see chat, so just bear with me while I struggle. I mean, maybe I can just do... I can do that for now. Yeah, okay. Alright, so I just want to make sure. I just want to get... Fuck, sorry. I just want to get the questions. Okay. Alright, okay. So now... I will be showing you the, question. Can I make this full screen? I cannot. Whatever. I'll be, like, taking a screenshot of the question, and then, I'm just gonna try and tell you, how I'm gonna go through it. This. If only I can speak. Alright, for 6, 8... and 16, we're supposed to be using the direct comparison test to determine whether the integral is going to be convergent or divergent. So I'm just going to get a screenshot of that. Ah, yes. I love how it blew up itself. Thank you. This is going to be great. I promise. Alright, so... fuck, direct comparison. I thought I had my notes on me. 1 second. These are not my notes. Oh. I, for a good minute, literally just thought I lost my, fucking calculus, notebook. I was actually about to cry. Alright, so the comparison test. It's not difficult. Actually, no, I could probably figure it out, the comparison test. I think I remember it. So now, with the comparison test, it's pretty easy to do. Because, if you wanted to integrate something like this, it'd be hard because of this. So instead of trying to integrate it, what we can do is just find something that'll be either less than or greater than. And if we think it's going to be convergent, we should try to find something that is greater than. But in this case, I think we should look for something that is less than, just see if it's divergent. So this will be greater than, let's say, 1 over 3n squared. Or actually, we get to leave in sum. That's 1. And it's going to be 1 over 3n squared. Because now this is something we can more easily integrate. I just want to make sure that is the correct case. Oh, wait. There we go. I actually have a page for equations. I think it was like a 650, I think. What page was it? 656. Yeah, I have a actual cheat sheet for equations, so give me a second. Ah, here it is. Okay, so comparison. Okay. And now all we have to do from here is just figure out whether this converges or not. Thank you, Stream Elements. I appreciate that. Also, I think I figured out how emotes work. I had to, like, get this brand new chat and just figure out how it works, and thankfully it did. Emotes are still weird because, fucking YouTube, but hey, whatever, it's better than Twitch. Okay, so now from here, all we have to do is figure out if this diverges or converges, and if it is what? And if this diverges, now this is truly the content we've been waiting for. Hello, Timid. Hello, how you doing? Now, if we figure out if this diverges, which I can already tell you the answer is yes, then it doesn't. Yeah, no, it diverges because if we were to find the limit of this. I'm just stuck in Jersey. Are you stuck in Jersey? Cringe. Unfortunate. Because if we were to find the limit of this, so it'll be the limit of n approaches infinity, we would get 1 over 3n squared. But I'm gonna try my best to teach it. I'm struggling to understand this, but since but if a fraction is ever going to infinity, like 1 over infinity, it will always go to 0. I guess the best way to look at it is by visualizing it. So, for instance, let's just say we have a graph, right? This is our y, this is our x. Okay, so this is 1. Yeah, so this is 1. We go here, and since it's going to infinity, since the fraction is 1 over infinity, it will just continuously, exponentially, it will never hit 0 truly, but it will go as close as possible to 0. I think this is the test for divergence, and since it actually just does go to 0, 0, I don't think it means anything, unfortunately. I think that means we have to use another test with that one. I just want to make sure. Test of divergence. Oh wait, actually, I have the cheat sheet right here. My bad. 1 second. Test of convergence. Is it there? It should be there. GMAS series. Oh wait, no. I think this is the Test cannot be used to show convergence. Okay, so it diverges if it does not equal 0. Okay, so basically what this means is, this means absolutely nothing. So what I just did right now was waste my time and everyone else's time. Thank you, calculus. I'm not even joking, by the way. That's literally how it works. Alright, so from here. I'm stupid. Right, I forgot. No, there's actually something easier we can do. So instead of doing what I just did, which was the test of divergence, we could have just done the thank you, whiteboard. We could have just done the P series where we look at the exponent of n. And if the exponent is actually greater than 1, dude, I'm skipping a lot of steps because I'm trying to do my homework, because I need to, like, actually understand what I'm doing. So, if you are confused, just ask a question. I'll be more than happy to answer you. Okay, so, what I'm looking at right now is, I don't think I can show you my, I don't want to show you my textbook just because, like, that's, like, an actual, like, legal issue. So, I'm just gonna take a screenshot of it. Okay, so this is the test of divergence, or in this case, the nth term. What we did was we took the series, and then we simply went and found the limit of it. And if the limit equals, if the limit does not equal 0, then it diverges. That means it will just go on infinitely. But since it did equal 0, that means the test Actually, no. I should probably mention this test cannot be used to show convergence. But now this means this test does not work and will not give us the right answer if we continue. So we have to find another method. So our next method is p-series. Actually, for the sake of it, let me also change this to something a little more accurate, because it's going to be... Oh, excuse me. I'm pretty sure I'm doing direct comparison correctly. I hope. Actually, yeah, for the sake of it, let's do that. And we'll look at the p-series, which is right here, the exponent for n. That'll be p equals 2, and 2 is obviously greater than 1. And in this case, it converges, but is due, or actually by p. Usually this would... I just spelled it right the first time. Usually this will also be true, but the issue is this is, in fact, less. Wait, no, I'm actually dumb. Forgot fraction. My bad. I'm making so many minor mistakes. We're looking at fractions. So technically speaking, this is less. Not technically speaking, this is just less. Because it has a greater denominator. And because of that, we can also figure out that it converges due to the... what? Due to p literally being 2. And since, what? In p-series, all I have to do is find the exponent for n. As long as it's greater than 1, it converges. If it's less than 1, it will diverge. Actually, wait. No. Yeah. So if the absolute value of p is less than or equal to 1, then it will diverge. That's it. So I guess I need to remember this. If p equals absolute... So if the absolute value of p is less than or equal to 1, diverge. If p is greater than 1, I know, this is high quality content. Alright, so I'm just gonna erase this now so I can actually... delete. Alright. So now the next question I have is 8. I can just screenshot it. Please. There we go. Alright. So, from here. Well, this is annoying. Well, actually, no, not that bad, since we're doing comparison tests, right? Okay. So, since we're doing the comparison test, we can actually just figure out whether or not we can actually pretty easily find a comparison. So, let's just say, in this case, this is less than the Lehman sum of n equals 1 to infinity. Let's just do 4n over 5n. And now in this question we actually have a geometric series. Usually a geometric series looks like something like... One second. Looks something like this usually. So it'll be ace of n to the... Actually, sorry. I made a mistake. It's supposed to be a constant. It has it over here. Yeah, okay. So a times r to the nth power. And it will diverge. And if the absolute value of r is less than 1, then it will diverge. If the absolute value of r is greater than or equal to, my bad, 1, then it'll converge. I can spell it occasionally. Okay, but how do we get this with this? You might be wondering. So, since they both have the same exponent, we can actually just do the Lehman sum of n equals 1 to infinity. We just have it 4 over 5 to the nth power. And don't forget, you can just pretend there's like a multiple, what? It can just be multiplied by 1 right here. So we have our a, we have our r, and we have our n. Now let's go back for a second. Let's go back for 1 second. Now, we see that 4 over 5 is actually less than 1. That is our r. And since it's less than 1, we can actually figure out that I messed up. Usually, if you're looking for something to diverge, then it will actually what you should do is look for something less than what? Less than this. Unfortunately, what I did was I found something greater than. Technically speaking, I am right in saying that this diverges, but that doesn't mean this diverges. The best way to describe it is if you find the Lehman sum that converges and that's greater than the original problem, then the Lehman sum that's smaller than it will converge. Using the comparison test, it will converge. And in this case, since I actually used the wrong comparison, either way, I actually used the wrong exponent anyway. 0, 0. But since I found something that's greater than, and I learned that it diverges, that unfortunately means nothing, and I have to go back and do it again. This is great. This is absolutely phenomenal. Alright, let's see here. So, I'm pretty sure I do have to. I just want to make sure I don't like overcharge my phone. Yeah, looks good. I do have to make sure I don't just. Also, I just realized my chat is just blocking it. My bad. I didn't even notice that. There we go. Okay, should be fun. I'm getting DMs. What is this? What is this? I'm streaming. Come on, guys. Alright. Why did it do that? Where did my thing go? What? Okay, so unfortunately, this doesn't work. I do want to say on the right track. I just have to find something that is much closer to what I'm looking for. This is a bit hard, I want to say. Friend doesn't even know that I'm literally streaming my fucking math homework right now. Alright, so... Comparison. Just want to make sure that yeah, because that just... Yeah, that diverges since... It is... Wait. Oh, no, I'm dumb. I looked at the wrong thing. It converges. I was just being dumb, because for whatever reason I was like looking at the wrong thing. Sorry about that. So now that we know that this actually converges, so we can write converges by was it geometric series? We can actually right here say this converges due to was a comparison test. I'm pretty sure it's what they call it here. Or yeah, direct comparison, I think. Excuse me. By direct. Did I spell comparison right? No, I didn't. I for love of God, I'll spell something right one of these days. Wow, I hope no one's confused. Ah! I'm just gonna pretend people are here so then I can actually, like, speak my mind and figure out what I'm doing, and when I do it, I'm gonna be like, wow, I actually know it's way better now. Alright, so now we're doing 16. So let me just grab a screenshot of that. Yeah, I feel like the, what is it called? The Organic Chem Tutor on YouTube. Literally my idol. I wish I was good as him. There we go. I had this mouse. I got this new mouse a while ago. It's like a Logitech, G502 SE Hero, but like it's very weird when it comes to precise movements. I'm not sure why. I like my sensitivity pretty high, so like, I don't know, whatever. So again, we're doing the comparison test, and wow, this one sucks. Wow, okay. Alright, so we can compare it to something like the Leibniz sum of n equals 1 to infinity of cosine of n over radical n. Now, in this specific case, I'm actually pretty sure that this is greater than, because of this plus 2. Now the hard part is actually trying to figure out what test we're supposed to use. This is a bit hard. So, for instance, I can actually just do a test of divergence real quick. So then all we do is just find the limit of n approaches infinity. And if it diverges, then as simple as that, we're done. So it's cosine of n over radical n. And if we take the limit of it, 1 second, let me we grab the calculator, because we're now trying to figure out whether or not the numerator goes to infinity faster than the denominator. So if I do that, it's a cosine of 1. About 1. That's how much I get. I think I have it in degree mode. I have it in degree mode. Let me do this again. cosine of 1, about a half. So then I do radical 1. Why did my voice crack? I don't know why that happened. Whatever. Radical 1. Ah. Okay. So bad news for us. This goes to 0. So limit is 0. This is because what is it called? Radical n just goes faster to infinity than cosine of n. Unfortunately, so it is what it is. We can try again with another number. Let's see, 2 for instance. Doing something right now. This is great. 4. Now if I do, let me just try cosine of 1. Cosine of 2, I mean. Aha. Okay. So this sucks. This is literally what this means. This literally sucks. Okay, let's figure this out then. Can I even find the integral of this, of cosine of n? I don't think so. I'm not even sure if we can find the, what is it called? This is something else. Alright, so. It's because of this +2 that makes me feel like it does diverge. So now we just have to figure out how can we prove that it diverges. That is the real issue. So the integral is positive and decreasing. It's positive and decreasing. I think. Oh, decreasing a minute. Whoops. Let's see. Okay. We can't do P series because of a cosine event up there. So then. And the limit, unfortunately, does just equal 0. Pretty sure. Yeah, no, the limit does equal 0 and it alternates. Wow, this is like really freaking weird. How would I even go about this? Do I have anything in my notes to even help me? Oh, wait. I think I found something. Ironically, my notes were just on the right page. Okay, so. Okay. I have an idea. So, instead of trying to figure out whether or not this is convergent, what we can do is actually just find the absolute value, if it's absolutely convergent, which is surprisingly easier. Because all we have to do is This. And now you must be wondering, how does this work? What changes about this? Well, you see, a moment ago I actually did learn that cosine of 2 actually becomes a negative number. And then I realized, like, it hit me. Because cosine of 1 is how do I explain it? Since it's alternating, it's always gonna be alternating around the 1 mark. So let me show you what cosine looks like. It looks something like this. So from here. So then we go from 0 to pi over 2 to 3 pi over 4 to 2 pi. But now since we're getting the absolute value of it, we're ignoring this part. And so now we're finding it when cosine is only equal to 1. And now in this case, we can actually write it out as the Leibniz sum of n equals 1 to infinity of 1 over the absolute value of n. And now from here we can actually find the p-series of it. The p-series, you might ask. Well, if you are in calculus, then you probably know that radical n is also equivalent to saying n to the power of 1/2. And so from there, if we set p, so now that we know what p is, so p is equal to 1 over 2. That means it is less than 1. And I was right, it diverges. Kind of. Because I just realized I messed up something. This means it does not converge absolutely, and I just wasted so much time doing this. So what I'm gonna do is cry and realize that I'm never going to become a computer scientist, and this is going to be my life for the rest of my life. So now I have to figure this out again. One of these days I'll figure it out. Yeah, this is hard. Yeah, this is, in fact, quite difficult, I might add. Maybe a limit comparison test. Can I do that? I wonder. It's the only one way to find out. I guess we can do, well, I saw it right here a moment ago. Just give me 1 second while I find, limit comparison. Okay, so then, let me actually try the ratio test, because that might actually work. Or maybe not. I'm looking at it now. No, it already... One way to find out. So if I were to do the ratio test, for instance, it'd just be, what is it? We're finding the limit of ace of n. So this is our ace of n. And approaches infinity. So now we're going to do cosine of n over radical n plus 1 all over cosine of n all over radical n. And now I have to figure out whether this is less than or equal to 1. Already I can tell you right now, since if we want to make this look a little bit nicer, we can actually just move the radical cosine up top, and that will just give us the limit of n approaches infinity of the absolute value of cosine of n plus radical n all over cosine of n. Aha. Okay. So, I think we actually have some good news. Technically speaking, since we're finding the absolute value, this constant, what is it? Everything here, technically speaking, since we know the absolute value of cosine of n is just 1, since radical n cannot be negative, because if it was negative, then we'll just be getting imaginary numbers, and that's simply not the case. And if we plug in the limits, and if we rewrite it so n approaches infinity, we will 1 plus radical n all over. Ah, okay. We have figured it out, boys and girls. So now we got rid of the absolute value signs, and we learned that this. Now we can see that this converges, because this is equal to infinity. Did I say converges? Diverges. So now we can actually write that this diverges by ratio test. I'm actually kind of impressed with myself. I know like no one's here right now, but I'm like very surprised that I'm able to write this out. My friends that good luck with the stream, I'm just telling him I'm doing Calc Live. So now that we know that it diverges by the ratio test, we can also say that this diverges by comparison test. That's easy. By there we go. Perfect. That's someone messaged me. Anyway. Excuse me. Wow, that was 2 questions, and it took us a total of... does it say how long we've been streaming for? No. Thank you, YouTube. I've been streaming for about 44 minutes. It took me 44 minutes to do this problem. Okay. Alright. Now on to question 22. There we go. Okay. Now we need to use the limit comparison test to determine whether or not it's convergent or divergent. So now, 22, I'm just going to write it out, I think it'll be easier. So 22 is 1 over n squared times n squared plus 4. I forgot to do the Lehman sum. There we go. It's gonna be, is it equal to 0? No, 1. N equals 1 to infinity. There we go. Okay. So now we're just finding the now we're just gonna try and find the limit. So if I do the limit comparison test, I just want to make sure I'm doing the right thing. B sub n. What is B sub n? Okay, let's see. I actually think I have it. So, okay. I just want to make sure I was looking at it right. Okay. So now we have to compare the limit. Oh, wait. Am I right? Wow, I wrote a terrible example for this. Okay, so let's see this again. So, we can probably compare it to something like, let's just say, for instance, because I'm pretty sure B sub n, or let me, B sub n, in case you're wondering. If I ever say A sub n, I'm talking about this, not A n. So in this case, what would be B of n? I only took better notes on this. Okay, so that's the thing. Alright, so B sub n is... So let's figure this out. Okay, so what I can do for this is make a comparison to B sub n, which would be, in this case... hopefully I do this correctly, because I wrote really bad notes for it. So 1 over n to the 4th power. Because technically what we have here is... And yes, I'm going to be writing the Lehman sum every time. It's good practice to get into. Is 1 over n to the 4th plus n squared. Technically speaking, this actually could have just been done easily by p-series, since we already know both are 4, and we can already tell that this converges by p-series. So, but we're going to ignore the p-series for now, because it wants us to do the limit test, which is very fun. Now, what I have to do is compare it. So we have to do A sub n over B sub n. In this very specific case, it's going to be 1 over n to the 4th plus 4n squared all over 1 over n to the 4th. And we need to find the limit of that, so n equals infinity. What my notes have here is kind of strange, because it literally just says the same exact thing, but it changes the words converge and diverge occasionally. Did I actually write diverge? No, I wrote it right. Okay. So So from here, we can actually just write very simply lim of n approaches infinity, and that equals n to the fourth over n to the fourth plus 4n squared. And from here, we can simply, very easily, just divide everything here, I'm talking about each individual number, by n to the fourth. So just imagine you're multiplying. So just imagine this, you're multiplying 1 over n to the fourth on the top, and you're multiplying 1 times 1 over n over 4 on the bottom. So then from here, we'll actually get, since since we're dividing by n to the 4, we're just canceling that out. This cancels out. This is going to be n squared. Sorry, just something popped right next to me, like out of the blue. That kind of like scared me. So now, what we have is, I put equal sign twice, the limit of n approaches infinity, and that equals 1 over 1 plus 0. Sorry, not 0. 4 over n. Squared. And now, since if we take the limit of this, we actually know that this number is going to infinity. So then in this case, it will if we take the limit, it will just be 1. Because it's going to be 1 over 1, or 1 over 1 plus 0, and then we get this number. Oh, speaking of this number, 1 second. There was something I saw on Twitter. It was I wonder. I can find it. Okay. Something I found on Twitter. And like people were actually like being fucking stupid and saying that this equals 9. It's the chat's blocking you. It's 6 divided by 2 times 1 plus 2. So let's like quickly just do the math here. All right, so I'm just gonna take a screenshot and just do that. All right, so we can actually just rewrite this simply as 6 over 2 times 1 plus 2. People are forgetting that it's not 6 over 2 times 1 plus 2. It is not this. If that was the case, I'm serious. If this was the case, then it'd be written as 6. What? If that was the case, it would be 6 divided by 2 parentheses 1 plus 2. And if you see here, there are no parentheses here. Even with following PEMDAS, this is wrong, because technically speaking, you can just simply you can add this to 3, but then you still have to divide. You have to divide that, which is 3. Yeah, but you still have to divide, but then you still have to divide that, and don't forget, it's still a fraction. You're not suddenly just multiplying 3 times 3. No. This is still being divided because this is 1 unit. I'm not dividing 6 by 2. I'm dividing 6 by 2 times 1 plus 2. And everyone on Twitter was saying that it's 9. Alright, so let's humor everyone for instance. So let's just say this is 3 times 3, and there we go. That is 9. When did you join Khan Academy? No, I'm calling... No. If I was in Khan Academy, I wouldn't be calling people retarded. I'm just telling people how actually stupid they are. Because, like, people on Twitter, like, literally just did not know. Did not know what this is. That's my boy. Hell yeah. Yeah, because... You know, like, after, like, years of calculus, like, I've discovered that, oh, okay, so it's 6 divided by this. And people were looking at it like this. Like, not like a small minority of people, like, a large majority of people. I'm pretty sure they're, like, it was just trying to gaslight people, but it doesn't change the fact that a large amount of people were adamantly defending this method. I just wanted to say that this was very fucking stupid, and that I will prove everyone wrong. That this is what it is. That's what you're saying. This is what everyone's saying. But no. It's this. It has to be this, right? Of course not. Fucking morons. Anyway. Now back to actual calculus homework. Alright, so now this is equal to 1. The limit is equal to 1, so I just want to make sure I'm doing this correctly. 1 second. So in that case, it does converge. So as long as c is greater than 1, it can either be divergent or... I fucking hate calculus. It literally just says C then can either both be series convergent or both series divergent. Sorry, let me reread that. Now that C is greater than 0, then either both series converge or diverge. This is great. This is phenomenal. But I can already tell you right now, B sub n, which is this, converges. So then in that case, since we did the limit comparison test, this, right up above here, this whole number, converges by limit test. How you doing, Colin? Have you come to make fun of my calculus skills and how I think about doing math? Because I tried explaining my methods of like how I do stuff in my math class, and everyone thought I was actually insane. I'm not like gonna call myself like a mega genius in that like, oh, they simply do not understand. One of my friends recorded me, and then like I actually saw how actually like mental I am. I am not qualified to teach calculus, and yet here I am live, talking to myself, so I can better understand where I went wrong. And I'm not even gonna lie, this worked out so well. I don't care that I have 0 viewers. This is great. I do not care, because I'm learning. What are we on now? So that was 22. Now 26. Because usually what I do is if I get like seriously confused, I actually look up the answer on what is it called? Photomath, because Photomath actually has textbook answers. It will just give you the answer. I don't look at how they do it because the way they do it is so fucking weird. I'm not gonna say the way I do it is normal, but like this is how I was taught, so I'm gonna keep doing it this way. So now 26 is... okay. My teacher fucking hates us. That's what I've learned. So it's going to be the Lehman sum of n equals 1 to infinity of sine 1 over n. My brother in Christ. What the fuck? And I have to do like the limit comparison test. Oh my god. Oh my god. Okay. So now I have to compare this with something. Let's just say, let's compare it to so this is gonna be our b sub n. And that's gonna be sine of 1 over n, let's make this larger. Minus 1. Okay. So now, what I just did there was fucking stupid. You're probably wondering, this guy lost his mind? Yes! The answer is yes. Okay, so now to find the limit of these two, of n approaches infinity, then we get a sub n, right? So we get a sub n, so all over huh. Okay. I've gotten this far and I realized that this is way out of my capabilities. Okay, so woo. All right. Yeah, this isn't this is No, this is like such a weird question. Holy shit. How would I even solve this? What would I even compare it to? Wow. Fuck it. What do I have to lose? Let me see if Photomath has what I'm looking for. If it doesn't, I'm going to be really sad. I'm going to potentially cry. And maybe, just possibly, shit myself. Just maybe. Alright, so I'm just gonna do that. Let me oh wow. Aha, it diverges. Are you shitting me right now? Wow, that was way more simple than I thought. Okay. So, what I did was wrong. You see how I use sine? I was told by Photomath that I was a complete moron and completely out of my capabilities. So what I should have done was I know. Absolutely insane. So now we find the limit of n approaches infinity, and that equals sine of 1 over n, all over 1 over n. That can be written as I don't know, I'm blinking out right now. Sine of 1 over n times n. I just heard the ice cream man, I'm sorry. And from here, I'm just gonna, I'm not even joking when I say this. I'm actually so fucking confused. But technically speaking, this isn't wrong. So it does diverge. Just the way they do it in Photomath is just like super fucking weird. Because they're telling us to substitute n with 1 over n? I mean, technically speaking, that works. Oh, okay. Actually, I understand how they did it. So what they did was they simply changed the limit, as in they converted to the limit of t approaches 0. And from there we can actually convert it. So in this case, t is equal to 1 over n. Oh, well, how do we get this? N is equal 1 over t. And so from there, we can actually just do sine of t over t. And that actually, if you know, if you took a calculus, then you should know that that equals 1. So, what does this mean? Apparently it diverges. How I think in this case, I'm trying to figure this out right now. Okay, so our b sub n in this case was a 1 over 2 to the nth power. This is really weird. But this diverges due to limit comparison test, because I just want to see how they. Well, since the value is infinite and positive, the series diverges. Ah, okay. So now, this series, since we know that this diverges, because it's infinite and positive, also because it equals 1, then we can actually then we learn that this fucking sucks. No. Since we learned that this is divergent, this is also divergent. I'm pretty sure this is a harmonic series, I'm pretty sure. This one specifically. And harmonic series diverge. So now we can actually write that this diverges due to limit test. That's a G. Shut up. By limit test. There we go. Okay. That was actually part 1 of the homework. Wow, that was that fucking sucked. Okay. Alright, okay, so what do we have to do now? 629. Alright, so let's go through it. I also have, I just want to make sure it doesn't say what class I'm in. I might not even show the worksheet, because I got like a practice sheet that I might not show, because I don't want my classmates to just come on here and be like, what the fuck is this guy doing? And like, again, I've been having like serious issues of just people coming onto my live stream, specifically my classmates, and just saying, "Oh hey man, how's professor's name?" It's like, my brother in Christ. Why? All right, so let me just go to the page, and that is page 629. What page am I on right now? No, I just need to go 9 pages. All right, so. Okay. So then, 1 second. No, okay, we're good. All right, never mind. I don't know. I'm tempted to. Yeah, I would just move to the side. All right. So now we have exercises. 629. 629, and that's gonna be there we go. So 10, 12, 20, 46, 53, and 57. Okay, so then 10. Zoom in a little bit so I can actually see. There we go. So now we have 10. There we go. Okay. Ooh, okay. So now in this case, they're just giving us what we're supposed to converge or diverge. And now there's yelling in the background. Unfortunate. So this is now, so now they're not telling us what to do. We have to figure it out ourselves, which is nice, but also kind of sad. But it'll be fine. But now we know at least, that in this very specific case, that this is actually alternating. So then it'll be, you'll see what I mean. So n equals 1 to infinity, and -1, n plus 1 of n, all over 3n plus 2. Okay. So from here we can actually realize that this alternates due to this -1 and its exponent right there. So that's nice. But now another issue is it's in a fraction, which is not that nice. There's no real way of rewriting it, so I guess the simplest way to do it is by testing its by doing the test of divergence. And if we get something that's not 0, then good news is we're done, it diverges. Bad news is we have to do another test. So for instance, let's just do it like this. So let's find a limit. N approaches infinity. It's going to be -1 of n plus 1 times n all over 3n plus 2. Okay. So from here, all we can really do is just plug in. Okay. I mean, technically speaking, what I could do is something like, for test of divergence, I can actually just simply, because they're all divisible by n, so because they're both top and bottom have an n, so I can just divide it by n. So like, for instance, I can just do this. So the limit of n approaches infinity, and then we'll get -1 n plus 1 all over 3 plus 2 over n. And in this case, this will go to 0, and this number will actually go to infinity. So then in this case, the answer is infinity, and it diverges. I'm actually going to check my answer to make sure I'm actually right about that, because this one I'm not too confident in, but if I am right, just know I'm simply a god. Guess what? Homie said, "Oh, do alternating series." Nah, fuck that. I did get the right answer by saying it diverges, but maybe I should actually do practice the other rule sets. So at least we know for a fact that it does diverge. So from here, what we can do I'm trying to find the example that I wrote down. So all right. So b sub n plus 1 must be equal to b sub 1. I don't know, I'll use b in this case, whatever. B. And the limit of b sub n must equal 0. Okay, so let me see. Oh, there's actually a perfect example that we have right here. Let me just make sure I wrote everything right. Okay, so then in this case, okay, never mind. I did it wrong. Shut up, you whore. Goddamn. Yeah, you think I'm streaming something else. Okay. Okay. Huh. Unbelievably, actually, what I did was right. Okay, so if we actually took b sub n, let's see. Just want to see how I did. Oh, I didn't finish it. Whoop. But technically speaking, what I did it right now was actually correct. I just skipped so many steps. Because for whatever reason, what I wrote down here, the negative one is just gone. Because I couldn't tell you actually. Oh no, that's b sub n. The hell's b sub n plus 1 then? I don't fucking know. Either way, this is right. No, not the pen. This is gonna break one day. I'm actually gonna cry. Because I don't know how to repair this. So divergent the diverges by test of divergence. Test of divergence. Okay. What I technically did was correct. Because you can actually just use this in alternating series as well. But I need to actually practice alternating series, so I might just go back and find a few problems that actually have. Unfortunately for me, I cannot find it. Oh well. I thought I had an example of it. I guess not. So, for instance, let's just go back to doing this. So this is 12. Okay. So this is gonna be a weird one. 12 is the Lehman sum of n equals 1 to infinity. And that equals -1 to the nth power all over e to the n. Technically speaking, this is a series of convergence. By we can do this. Since they both have the same exponent, it's literally just limit of n equals 1 infinity. And then it's just going to be -1 over e to the nth power. I want to see if that is even allowed. I want to see, like, this is like, oh, like, is this okay? Am I allowed to do this? Because it is alternating, which is what is bothering me. Do I have alternating? Do I have alternating? What the fuck is alternating? I swear I had alternating. Hello? Am I dumb and didn't write alternating? By comparison, the answer is yes, I am dumb. I got a notification on YouTube. What is this? Yes. Sam Hyde's fish tank. Unbelievable. I cannot believe, and I was right. It was right here. So, if we look at this correctly, this is technically decreasing. No, yeah, not technically. This is decreasing. So then in this case, I'm actually not too sure. I really don't know how I did this. Like, I'm not trying to, like, to hide it from you guys. Like, haha, you don't know. But I'm trying to explain what I did on my paper, but I just simply cannot. Maybe I wrote it down somewhere. Oh my god, there's a example. I wrote an example. Holy shit, unbelievable. Okay. I figured it out. Because I actually wrote an example. Okay, so for this instance, we can actually just write. We find the limit of this. This is actually just going to infinity. But okay. Okay. So now we have to figure out whether or not let's ignore this for right now. Alright, how about this? Let's ignore this for right now. And let's just figure out what is the b sub n. So b sub n plus 1 will automatically make this. So for instance, what I'm looking at is if b sub n plus 1 is less than or equal to b sub n. So b sub 1, I think? Yeah, b sub 1. Want to make sure. Yes. I want to make sure it's I want to make sure it's less than or equal to b sub 1. Let me move it a little bit. So in this case, it is, which is very good for us. So that means we can simply find a limit of n approaches infinity of 1 over e to the n. Okay. So I wouldn't say too difficult, because this is the limit, then this goes to infinity, so then it equals 0. I want to make sure I did it right. Okay, yep, the limit does equal So the limit does equal 0, which is perfect. Okay. So now from here, what we did was, one second. So now what we did was we found now that we found the limit of that, we need to find the derivative of this. So then technically speaking will be f of x of 1 over e to the n. And I'll find the derivative of this, so f prime of x equals, and it's going to be, so e to the n minus e to the n all over e to the n squared. I don't know why I put n, it's supposed to be x, my bad. And if you haven't realized yet, this equals 0. And wait, technically speaking, if I wrote down my notes correctly. Okay. So then I'm pretty sure it has to be less than or equal if only I wrote better notes. Okay. So, yeah. I feel like a buffoon sometimes, and this is one of those times. In this case, I think it would actually be, oh my god, yeah, we switched to YouTube. It's crazy. How you doing, Christian? Totally doesn't have my full legal name. Unfortunate. Better than Facebook though. I will say it's better than Facebook because at least you're able to change it. On Facebook, you have to use your real name if you want to chat. I'm just casually trying to figure out if I actually did this problem correctly and whether or not it diverges. And I'm looking for textbook answers, and this is 12, and I'm pretty sure I can just snap it. It converges. Ah, okay. For legal reasons, this is my name. Okay, Dennis. Okay, Dennis. Sure it is. So good news is, I actually got the right answer. This converges. Is by alt series test. How are you doing, cool kid? It has been a while. I hope my chat isn't like terrible, because I like had to like install like a brand new program just to make sure it actually works. Well, good news is it doesn't look like shit. There we go. Mathematics, bro. Get good. Bro, get good at my job. It's so easy. I don't need to count past like 128. It looks cute. We're running out of numbers. What the fuck does any of this mean? Okay, so that was 22. It was 12. Now it's time to do 20. This is great. This is great. Now you get to watch a madman try and do calculus. Oh my god. Oh fuck. Shit. Alright, so n equals 1 to infinity. The limit sum of n equals 1 to infinity is 1 negative 1 to the n plus 1 times ln of n plus 1 function based the exponent of your mom of n plus 1. Okay. All right. Oh no. All right. So, we should probably find the beast of n, which is hey, I know that formula. Do you really? Aren't you like a fucking music major nerd? Jesus fucking, I'm just looking at this like, how did I get in this position? How did I end up here? Alright, so we want to know if the beast of n is wow, alternating series is a fucking bitch and a half, isn't it? My god, dude. Okay, so in this case, we can just write this as, I don't know why I wrote that, whatever. Beast of n equals ln n plus 1 all over n plus 1. And then if we find the limit of that, n approaches infinity. If you're confused, don't ask questions, because I'm also confused. Limit of natural log of n plus 1 over n plus 1. Aha, okay. From here, we realize that I am incapable of doing calculus. They both go to infinity. But we need to figure out which one goes to infinity faster. And I'm pretty sure this one goes to infinity faster, I want to say. So in this very specific case, I think it will just be the limit of n approaches infinity would be 0. So then we're already off to a great start. My life is over. Now I have to plug it into a function. So f of x equals ln of x, I almost drew an n, plus 1 over x plus 1. Now we get the f prime of x, and that equals to x plus 1 times 1 over x plus 1. Imagine getting infinity, but like at a rate of 0. I explained this earlier. Okay. So, for instance, if we have 1 over infinity, or let's do this, 1 over n squared. This is essentially just saying 1 over infinity, and just, this is the graph. This is the graph. Look at that. Look at that. It just goes down. It goes down to 0. It converges. Fucking nerd. Couldn't be me. And they calc for... My brother in Christ, this is calculus too. What are they teaching you? Yeah, actually, what in God's name are they teaching you? Holy shit. Alright, so then we have ln of x plus 1, and that is times 1. Jericho non-depth, so, oh, okay. That is equal to x plus 1 squared. Perfect. Okay, so from here we realize that this just immediately cancels out, so now we just get a negative, negative ln, it's an h, ln of x plus 1 all over x plus 1 squared. Okay. So now that we figured this out, why? Yeah, I actually put that wrong. Yeah, you're right. This is something you learn in Calc 1. When finding the derivative of a fraction like this. So x over y. This is what you get. You get y times derivative of x, or x prime, as I'm gonna say, minus x times y prime, all over the denominator. So y squared. That is how you find the derivative of a fraction. There are a lot of patterns you'll see, and I know, thank you, I'm indeed the most sexy man alive, because who on earth does their fucking calculus homework on Twitch to an audience of 2, 1, I don't know, all I know is I'm streaming calculus, and I'm learning that I'm incapable of doing this. Alright, so the good news is that we can actually already determine whether or not this is less than or equal to 1. Just by, excuse me, this negative sign. Unfortunately, we cannot get, excuse me, yeah, unfortunately, we cannot get, a definitive value, but because of that, I'm pretty sure this series would also be, would it be convergent? I'm pretty sure this series would be convergent. I don't know. I have like the textbook answers. This seems hard. Kirby, what are you talking about? This isn't hard. This isn't hard. You're out of your mind. This is very fucking hard. I'm trying my best to fucking discover this. Oh, I realized I was blocking the kit. So we end up with this number, and I'm gonna figure out right now whether or not this is correct. So what was that, 20? Okay, it diverges. Apparently this diverges. How? How? It doesn't say. It doesn't say. No. Wow, I'm not even like making this like as like a joke. It literally just doesn't say how it diverges. I'm not talking about like photo math, because I'm not expecting it to give me like a definitive answer. I'm talking about the textbook itself telling me that the alternating series only tells us whether it converges, and does not tell us if it's being if it's divergent. So everything that we did up to this very fucking moment was completely pointless. It follows that it's... Okay. Let me I'm losing my mind. Oh! There we go. Okay, that's it. That's what we're looking for. Yeah, it diverges. No, it diverges, right. How would I, how would I explain this like a normal man? Okay. So, from my notes, if b sub n plus 1 is less than or equal to b sub n for all, then b sub n is decreasing. That's a given. So, for instance, let's just do, in this case, so we have our b sub n, so let's just add a plus 1. So, b sub n plus 1 is equal to ln of n plus 1 plus 1 all over, I'm just going to simplify it now, I don't know why I did that. N plus 2. Okay, so from here we actually learn that it is in fact less than. So we could use the alternating series. Yeah. And since we found the limit, it actually does equal 0. So in this very specific case, I actually want to make sure that this is 0. Maybe it will tell me. I need confirmation that this limit is in fact 0. Okay. It didn't work. He says confidence and Riz. My god, I wish I thought of that earlier. Yeah, so technically speaking, again, yes, this is gonna be less than or equal to b sub n. So that's true. We figured that out, and I'm confident with saying that this is also equal to 0. Why wouldn't it be a better question? I mean, I could figure this out right now. Alternating series, perfect. Okay, so then let me do a little cheating, cheat. I'm not cheating. I just literally don't fucking know anymore. So what I realized, this is a little too complicated, so I'm just gonna find the limit of something. Just gonna add this one. So just bear with me while I write this out. So ln of x minus 1 plus 1. I'm a fucking idiot, my god. You'd be surprised, I actually have a pretty good grade in calc too. I put equals, my fucking god. Didn't even know I could do that. X plus 1. I've realized that the god is not in fact on my side. This is what... God hates me. But I think I am right by saying that this is equal to 0. Because for, how about this, I just plug in my calculator real quick. If ln of 2, simply put, 1 second. What's ln of 2? 0.6. There we go. Okay, yeah. No, immediately, what, I already proved myself because 2 is greater than ln of 2, so then obviously that actually goes to infinity much faster, so then that is true. This is true. But why is it divergent? But why is it divergent? That's the one thing I don't understand. This is fucking hard. This is painful. Wait. So, what we can do, what I just looked at, is find the limit of this. We find the limit of this. Approaches infinity. Of minus n plus 1 of ln of n plus 1 all over n plus 1, and divide each individual number. So this one, I realized my camera's blocking it, my bad, sorry. So we divide each individual number, so this entire unit and these two numbers by n. We will get negative 1 n plus 1 ln of n plus 1 over n actually that's it. This is actually it. This is our confirmation that it is divergent. Wow. Wow. Holy shit. Okay. No, it'd still be there because technically speaking. No, because the n is still here. N is still there. You remove because this will just be 1. This would be 0. That would be 0. But in this case, it'd also be 0. So what exactly am I missing here? Alright, so we can't do it since it's... Alright, so... I'm not wrong for thinking it, but I can't do it since it's ln. Because it's ln, so I can't simply just divide it by 0. Sorry, divide it by n, my bad. But if I was still to do this, and then... I wish I had, like, just, like, an explanation to why it's divergent, because at least, like... Because, again, at least with, like, the one downside with Photomath is it sometimes explains why it's divergent, sometimes it doesn't. In this case, it just does not tell me why. It's just saying alternating series test deems it divergent, which doesn't help me at all. Yeah, you think having the textbook answer would just help you, but no, it doesn't. The given series diverges. No. Because with the... What's that? With this, we're looking for B sub n. This is our B sub n. What we did up to here is actually correct. But I think we just simply blundered it up because there's something that we're missing that makes it just not correct. That just makes it negative. Not negative, what am I looking for? So, a sub n has to be greater than 0. Okay. Already know that. So then, in this case, if it converges, if that's true, and a little bit of a sub n, limit of a sub n. Limit of a sub n. Wow, okay. This is like actually really hard. Yeah, I'm saying the result being an everyone. No. This is natural log. Natural log. This is 1 unit. So it will only cancel out if it was ln, but it's not, unfortunately. This is the natural log. So like if we were to find like the derivative of this, which is like right here, the derivative of ln is literally 1 over whatever is in here. It's a completely different number since this is a natural log. Yeah, that was it. Okay. So then this one is our problem. So then, again, I don't think what I'm doing right now is wrong. It's just that we're missing something that just screams at us for it being divergent. I just got a message on Discord. Wonder what it says. I hope it's my friend who's like really good at calculus. It is not. My life is over. My life is ruined. Oh. What did I have earlier? Okay. I forgot. One second. I guess let me show you an example real quick. So, just want to make sure it was in the right place. So in this case, this is a harmonic series. This one diverges. Okay. Now it's starting to make sense. Well, yes, I guess you can say that this limit does, in fact, does equal 0, but it, I guess, yeah, no, I guess it's as simple as that. It just diverges. I think I'm just going too far into this. Diverges by. If I can. Alternating series. Okay. Next question. 46. Oh boy, I wonder how. You gotta enjoy the gym. Alright, enjoy the gym, homie. I'm gonna suffer by working out in this gym. My brain. This fucking sucks. Have a good one. 46. Oh, god damn it. Well, what am I, absolute... Okay. Okay, diverging absolutely, finally. This could actually save my life. Alright, so 46. The Lehman sum of n equals 1 to infinity of -1 n plus 1 all over n radical n. I mean, it could have written 3 over 2n, but it doesn't matter. Because since we're finding the absolute value of this, I'm pretty sure we can write it as Lehman sum of n equals 1 to infinity, the absolute value of -1 n plus 1 all over n radical n. And since it's an absolute value, this means this can never be negative. And then 1 over n radical n. I want to make sure I'm just doing that correctly. Oh, okay, okay. Absolute convergence. And, right, okay, so then from here, we can go back to using p-series, because if this one converges absolutely, then this one converges automatically. So then in this case, p is equal to 3 over 2. Because square root and there has to be 3 if there's an extra additional n outside the radical number. So then in that case, that is actually greater than 1. And if I remember correctly, it should be divergent, right? No, not divergent. Convergent. And that is correct. Okay, so then absolutely. So then this, in this case, is absolutely convergent. Converges by being absolutely convergent, because the way I think think of it like this: a absolutely convergent automatically makes this convergent. Did I spell it right? I spelled it wrong, I'm pretty sure. But you get the point. So, in this case, how would I write it? So, in this case, I can actually just write it as converges by p-series by p-series, and then this automatically and then since this converges, this automatically makes this absolutely convergent. Put a D. ABS absolutely convergent. There we go. So this is absolutely convergent. What's the next number? That was actually fairly easy compared to what we were doing with literally 5 minutes ago. 53. Okay. 53. This is gonna be what the... Oh, actually, this is like easier than it looks. I hope. So, this is gonna be -1 or n all over 2. I forgot to put the limits on, my bad. Okay. It's good to know it starts at 0. Alright, so n equals 0 to infinity. This is gonna be -1 to the nth power to 2n plus 1 factorial. Alright, so again, if we were to take the absolute value of this, we would get 1 over 2n plus 1 factorial. That's what we get for the absolute value. I mean, I'll write it out regardless, because the absolute value of this will always be 1, no matter what. So we can just remove the exponent from that entirely. And I guess we can just find... We can find the limit of this. And the limit's gonna always be 0, because the limit of any factorial is always 0, because it always ends. it doesn't go it does not go infinitely. There is an end to every factorial. So while n grows infinitely, while n continues to grow, it will always end at the same place. Think of it like that. I wonder how if I have an example using a factorial. What in God's name? What the fuck? I found an example that uses a factorial number, and yeah, trust me? Nah, this ain't it. This is not it. Oh, right. Okay, that's weird. I forgot that was a thing you can do. Okay. So, with this, if we were to find the limit of this, n approaches 1 over 2n plus 1 factorial 0. So it's not divergent, we know that. So it has to converge. How, you might ask? Okay. My father's watching soccer upstairs. Alright. So from here, we can actually use just a different test to figure it out, because that what I just used was a test of divergence. So, in this case, let's figure out what would be the best test to use in this very specific case. So I think in this case, because we're trying to find this we could do ratio test. I think that'll work. So in this case, if we want to do the ratio test, it would be limit of n approaches infinity is, so this is, I want to make sure this is ace of 1, so then we're going to do ace of 1 plus n. So in this case it would be, let's go have the absolute value because it's there, the absolute value of 2 times n plus 1 times, plus 1 factorial. Very important. That's over 1. And normal ace of n. So this is going to be 1 over 2n plus 1 factorial. Okay, so now, how do we find the limit? First of all, let's make this a little easier for ourselves and just write this limit of n approaches infinity, and then we'll simply multiply it. 2n plus 1 factorial. I'm going to simplify this, so it's going to be 2n plus 3 factorial. Now, the thing about factorials is, since they end, you're constantly subtracting 1. So what you can do, very easily, is just spread it out. infinity. Hopefully I don't block it. So from here, what we can do is just 2n plus 1 factorial over 2n plus 3, 2n plus 2, and 2n plus 1 factorial. From here, these cancel out. I'm going to move this down a bit. So from there, those cancel out. And then we get the limit of n approaches infinity of 1 over 2n plus 3, 2n plus 2. And from here, we can, I guess we can simplify it if we want to, and that will just be, I'm not gonna write the limit because it's still under the same limit. 1 over 4n squared plus, I'm blanking out right now. I'm blanking out for no reason. 7n plus 6. So I just want to make sure nothing important happened. Alright, never mind. Alright. And from here we realize that this converges at 0. Not infinity, which is good. And I just want to make sure I did my ratio test correctly. And, yep, that is correct. This is absolutely convergent. So all I have to do is write absolutely convergent. A, B, S. And convergent by ratio test. How the fuck did I get a negative viewer? What the fuck is this? What in God's name is this? I'm not even shitting you. What is this? Literally how? How? How does this even happen? Literally how? Like I'm not even like mad. I'm not even like mad. Just how? How does it even happen? Oh my fucking god. Alright, okay. Okay. So let's do 53 now. Nope. Let's do 57. That was funny. That was fucking hilarious. Negative concurrent viewers. Let's fucking go, guys. First stream ever to stream to a negative human being. Alright, anyway. So let's just do the leaving sum of n equals 1 to infinity. I already fucking hate this problem. I'm gonna let you guys know right now. Cosine of n pi over 3 all over 2n squared. It might not be that bad. Because cosine is not always positive. So actually, if we find the absolute value of cosine, it would just be 1. So we can just rewrite it as n equals 1 to infinity. 1 over the absolute value of... Oh wait, actually no, it doesn't need an absolute value. I'll just write it for the sake of it. So cosine of n pi to the third all over n squared. Alright, so if we're to take the absolute value of this would just be 1. So I'm just going to write it 1 over n squared. Because now this is impossible for it to be negative. Because it's a squared number. And just from here already, we can determine if it's, we can already tell it's convergent. This is convergent by geometric series because of this one. If you want to look at it a little differently, it'll look something like 1 times 1 over n squared. Oh, wait, no, not geometric series. By p series, my bad. Holy shit, I'm not thinking of it. I forgot that geometric series only works if the n is an exponent. So by p series, p equals 2, and that's obviously greater than 1. So in this case, converges by p series. And now all I have to do is write absolutely convergent. Wow. I'd actually say we're doing pretty good. There are a few problems I definitely need to go over, because some of them are just, wow. Like, what the fuck? Absolutely insane. But at least I'm able to look at this, like, I mean, at least I was able to look at that and instantly figure out, okay, no, it's as simple as that. I just want to make sure I'm not crazy. in my Discord, Max just simply said, holy moly, someone stole a viewer from you. Literally, I'm not even mad. That shit was so funny. I'm gonna check to make sure that what I have is correct. I'm confident that this is correct. I should probably check whether or not my last question was correct as well. And absolutely convergent by comparison. Wait a fucking minute. Wait. Let me figure this out right now. I'm really scared. Cosine of pi over 3. Oh no. Oh no. Cosine of 2 pi. Oh, okay, no, I was actually right by putting that there. They did the comparison test, which is not wrong, because yes, you can literally just write this. Technically speaking, there are no issues, so this is both correct. I forgot music was still playing. Let's change it to like a different radio. Let's do this one. Okay. Ow, fuck. Okay. So I think we're almost done because that was the last question of this set of problems. Okay. So then in this case, we're on our final set of problems, which is page 637. $20, $26, $33, $42, $50. All right, there we go. Okay, so now have to go to page 37, which is 7 pages ahead. I can do math. My arithmetic has just been getting continuously worse by doing calculus, which is kind of funny. So that's gonna be shit. Why am I forgetting? You see? You see? Like, I forgot what fucking 9 plus 7 is. I'm not faulting myself for like being bad at arithmetic, but like Jesus Christ, what happened? I used to be like so good at this stuff. 20. Okay. So 20 using the ratio test. Okay, I have to use the ratio test for this one. So now 20 equals the Lehman sum of n approaches 0 to infinity is 2 to the n power times n plus 2 factorial. Let me make sure I'm doing my ratio test correctly. I don't want to accidentally just fuck it up. Okay, yeah, it's as simple as that. Okay, so from here we have to find the limit of this, and it's going to be, I'm pretty sure I wrote it down earlier. If we want to find the limit of this, it has to be n equals n approaches 0. I mean, really quick, we can also figure out if it diverges or not. So now I put 0 infinity. And I already told you guys right now that it already that the test of divergence just does not work because it equals 0. Because again, factorial always equals 0. Especially if you're finding the limit of it. It will always end up at 0 because it ends. No matter what. Alright, so then we're gonna do a very nice and simple number. 2 to the n power plus 1 over n plus 3 factorial, and that's going to be over 2 to the nth power all over n plus 2 factorial. Alright, so time to simplify. Wait, am I getting the absolute value for this? This is actually pretty important if I do. Yes. Okay, so for ratio, I do have to take the absolute value. Alright. So, in this case, it's going to be limit of n approaches infinity. We're going to get 2n plus 1 times n plus 2 factorial all over 2n times n plus 3 factorial. I'm just gonna do a lot of I'm just gonna skip a couple of steps because I already know how to get from here to here. So I might just write it out somewhere else and just erase it. So from here, from earlier problem, if you remember correctly, you can just simply subtract 1 from this factorial and get n plus 2 factorial. And that simply, and after doing that, we can just divide that, so that removes the factorial. So it'll just be n plus 3, and it'll just completely remove this number. So that's good. And now from here, we have 2n plus 1. We can also write that as, because that's the same way of saying 2n, so 2 to the nth power, times 2. So, what we can do is actually remove the n from there. Because if we divide by the 2 to the n, that simply just removes the n and leaves us with 2. So then what we should get is the limit of n approaches infinity is equal to 2 over n plus 3. I want to say it's pretty good. But now I just want to see what I did, because there is a factorial problem. I don't know, the way they did was actually completely different. Oh, we did it, let me phrase, it's completely different. So technically speaking, what I have now is just this. So I'm pretty sure this is divergent, because again, the harmonic series is just an n with an exponent of 1. I want to make sure at least I got that correct. That was blurry. Why? For whatever reason. Thank you, Photomath. It's convergent. Okay, then. How? Let's work. Okay. Yeah, they also skip a lot of steps too. So. Ah, okay. I figured it out now. Hey, so I wasn't crazy for thinking that, well, yeah, we can just simply from here, from this problem, divide out every individual number by n. So then we'll get a limit of n approaches infinity, and that's gonna be 2n. If I do this correctly, that's just 1 over 1 plus 3n. And due to the ratio test, I'm pretty sure, if I'm looking at it correctly, it has to be less than 1. And from already, 0, 0. Convergent by ratio test. Kind of impressed myself. Okay, so I'm surprised I'm doing this like so well. I thought I was gonna like fuck up immensely, but no. Here I am. 26. So now 26. This is gonna be let's see here. 26. Okay. Excuse me. So this is gonna be limit sum of n equals infinity. N equals 1 to infinity by negative 1 n plus 1 times n plus 2 n times n plus 1. I mean, I can just like, I can actually just simplify that as just, we're doing it at 26, right? Yeah, okay. So n squared plus n. I can simplify that. It'll be easier once you realize why. So now we're finding the ratio. We have to take the absolute value and add what plus 1 to n. So from here we can simply just do the limit n approaches infinity is, since it's absolute value, this is gone. We don't have to worry about this because there are no negative numbers with absolute values. So it's gonna be n plus 3 over n plus 1 squared plus n plus 1. Alright, now this all over n plus 2 over n squared plus n. Yeah, there we go. Okay. I don't know why I thought it was going to be something else. No. So that's, again, absolute value, so we don't have to worry about the negative number. All we do is just simply multiply this bottom by this top, and you should get... And you should get... approaches infinity. So n plus 3 times n squared plus n all over wow, this is a fucking weird one. Because that multiplies to that, and this multiplies to this, so then it'll be n plus 2, this in brackets, n plus 1 squared plus n plus 1. Okay, so from here we can actually just rewrite this one, as I'm going to do right now. 2, we'll put it in brackets as well. N, or actually just do that, n times n plus 1. Aha! Now we figured it out. So from here, we can actually just set this to 1 and set this to n plus 1. So then that'll be n plus 2. And then we'll get n approaches infinity. So let me write infinity correctly. Infinity equals n plus 3 times n times n. All over n plus 2 squared. Because, since this is equal to 1, that actually opens up this parentheses. And then these two combine, n plus 2, n plus 2 squared. I guess for the sake of it, we should also, actually, yeah, let me... Instead of doing that, let me actually expand it. So then, we remove this one. So then we will get the limit of n approaches infinity. And it will be a very simple n squared plus 3n on top. And n squared plus 4n plus 4. From here, I want to say pretty easy. Divide everything by n squared. We should get... If we divide everything by n, we should get a very simple 1 plus 3 over n, so that equals 0. And this is going to be 1 plus 4 over n plus 4n squared. So, 0, I'm going to write down here, 0, and 0. 1. And if we look at the root test, is that what we're doing right now? Yeah, ratio, my bad. Or the ratio test. Okay. Ah, well then. So, the ratio test is inconclusive because it equals 1. I think it's asking us if we can do another thing, and if the ratio test is inconclusive, determine the rate convergence or divergence of series using another method. This is great. This is great. I hate this problem because it literally just says, "Yeah, waste your fucking time, you moron." This is not me making a joke. This is literally what it is. So we don't know whether or not if it's convergent or divergent, since the test came out to be inconclusive. So what we can do is probably do the alternating tests. I want to see if I have a better example of the alternating test. Alright, so instead of this, we're just gonna look at it as base of n equals n plus 2 over, I'm going to actually write out the full thing, n times n plus 1. Actually, no, since we're finding the derivative, it actually will be easier if I wrote out condensed, or simplified, n squared plus n. So then in this case, it'll be f of, first of all, let's actually find if it's convergent, first and foremost. And I guess the best way to do that is actually running it like this. Okay, so then we should find n approaches infinity. After we find out if it's convergent or not, we're gonna figure it. Only one way to find out. So does it diverge? Better question. N plus 2 over n plus 1. Alright, so from here we can just divide everything by n. Not n squared, it has to be matching, so this would be divided by n, this would be divided by n. So then in this very specific case, it would be equal to 1 plus 0, because divided by n goes to infinity, all over 0 all over 0, because, or 1 over, sorry, that's actually just 1, n plus 1. From here we can actually tell if this is actually divergent, I'm pretty sure. I want to say it is divergent at least. Let me see if I do, let me take the limit test. Limit test. End term test. Right, it doesn't show. Great, why would I think it would show? I know I have an example of it somewhere. Not integral test, we don't need that. Test of divergence. There we go. Is there another example of test of divergence do I have? I definitely should have it. Well, I was right about this. Right, yeah, of course it equals 1. 1. Because this goes to 0. Plus 1. So, diverges due to test of divergence. by okay, that was actually easier than I thought it was gonna be. I'm gonna be honest. 33. Excuse me. Oh. Huh. This is a weird one. So it is 6 to the nth power. Let me write the leaving sum, my bad. N equals 1 infinity. All over. And, oh. 0. All over n plus 1 to the nth power. Then you could also write that as 6 over n plus 1 to the nth power. All to the nth power. There we go. You can write it like that. It doesn't really matter. Since we're doing the ratio test, we still need to... it doesn't really matter at all, actually. So what we can do is just... lim. Would it be easier like that, actually? Let me see. I'm going to try it like this. Of n approaches infinity is going to be 6 over n plus 2, because we're adding, because since we're doing ratios, it has to be plus 1, n plus 1, all over. It actually could work, honestly. It could definitely work. Because if we can write it as 6 over n plus 1 over... no, we can't. Never mind. Plus 2 right here. No, it does not work like that. N plus 1. Okay. So, it would have worked if n wasn't here. But since it is, nah, we kind of have to suffer with it now. So, my idea is to... Sorry, I thought my microphone was too loud for a moment. So I'm just gonna add... Why did I put plus 1? My bad. There's no plus 1 here, it's just supposed to be n. So I'm just gonna revert it back to this. It'll just look... It'll be the same question, it'll just look a little different. So limit of n approaches infinity. I need more water. It's going to be... Okay, so... Wow, this is such a weird problem. 6 plus 6 n plus 1 times n plus 1 to the nth power. And this is going to be n plus 2 n plus to the n plus 1 power times 6 to the nth. Right, so if everyone remembers correctly, we can simply just split this up. So then it'll just be 6 times, it'll be 6 to the n times 6. And we'll simply just get rid of, just get rid of the n, because now we're moving 6 to the n. So it'll just be 6 times, let me write it over here. Hopefully I'm not going to block the important part. Of n approaches infinity. It's going to be 6 times n plus 1 to the nth power. All over n plus 2. And, wait. This gets removed. N plus 1. Okay, I actually didn't block it. Nice. That's what we should end up with. What we can do if I guess we want to make it look a little nicer, we can do 6. Limit right. N approaches infinity is 6 times. It'll be 6 times 1. Actually, yeah, it actually will be n plus 2. I don't know why I put parentheses. Times. Because we can't write it like this. We are 100% allowed to write it like this. N plus 1 all over n plus 2 to the n. We are able to write it like that. So, it is not a harmonic sequence, because if we just divide everything by n, we'll be dividing this entire thing by n, because of this exponent. So in this case, we're kind of stuck at an impasse. It is thankfully not gonna be 1, because this is going to be because this has to be an exponent. There are simply more n's, and if I were to simplify it, and if I were to simplify it, it would just be 6 times n to the n plus 6 times 1 to the n, which is just plus 6 all over n, the n plus 1 plus 2 to the n plus 1. We can write it like that, and it's 10, and what I wrote is comparable, because 1 to the power of anything is just 1, so it doesn't matter, so it's automatically 6. Nothing can be simplified from here. As a matter of fact, if we were to try and simplify it, it will just be 6 times n to the n to the power of n plus 1. So nothing really changes over there. With this one, since it's plus 1, nah. We kind of can't. So... I guess if you really, really want to, you divide everything by n plus 1. No, actually that won't work. That actually won't work at all. So... This is a tough fucking problem. Wow. Okay. I was actually pretty confident I can do this. Now, so that I'm having doubts. It's not that I'm having doubts, it's just that this is a really strange problem. Because of that No, never mind. Actually, that doesn't work. You cannot do, Let me see what the answer is. I can probably figure it out from there. 33. Maybe I'm on the right track. So it is convergent. Okay. What I did is actually entirely correct, which is nice. Oh, I just realized I can remove the 6. That's entirely that's entirely a thing I can do. Remove, put it off to the side. And Oh, holy shit, dude. What? I literally would have never figured this out. Okay, so what I have here right now is 100% correct. I know, like before, like you even like say anything, what the fuck is this guy talking about? No, this is 100% correct, because this, in a way, is just saying, and I cannot believe my fucking eyes. This is gonna be a real pain in the ass if I forget about this. This is saying 6. The fuck? Sorry, no, I thought like the thing was like loose, but there's like there's no seam. I don't know what the hell that was. 6 times e to the negative 1 times 0. This is 0. This is e to the negative 1. And that equals 0, and by definition, this converges because it is less than 1. So, converges by ratio test. Man, Twitter would be going fucking off right now. Fucking testing the ratio, doing a ratio test just for their sorry ass. Anyway, wow, that was difficult. 42. Wow, this can't be any harder, right? Also, by the way, I would have never figured it out if I didn't look at Photomath. I'm telling you right now. I don't like cheating. Like, I like actually learning what the hell's going on. But this is something you learn in like pre-calculus, and I forgot everything from pre-calc. No, not pre-calculus. I forgot what it was. I don't think it's linear algebra. I don't think it's that. Okay. Use the root test. Wow. Okay then. The root test. All right, I have to remember. I have my notes open to that, so it'll be fine. I remember this one not being too difficult. The root test. It's like, I want to say fairly easy comparatively. So it's gonna be n minus 2 over 5n plus 1 to the nth power. That's 42. And now if I were to go to the root test, no wait, no, I'm a little bit behind. There we go. Where's the root test? Root test. Root test. Ah, here it is. Root test. The root series converges at absolutely when. Ah, okay. So when the absolute value. So it has to look something like this. Ace of the absolute value of ace of n. So if it's greater than 1 or equal infinities or equals infinity, then diverges. If it is less than, that's greater. Greater than 1 diverges. Same thing if it equals 1. I'm just gonna do plus equals 1. Wait, no, 1 equal 1. Sorry, equals infinity. Equals 1 inconclusive. Okay. So all it has to be is less than 1. And since it's already with an absolute value, we don't really need to worry about negatives, as long as it's less than 1. So in this case, let me just see how it's written. I want to see. Okay, so over in the root test. Yeah. Oh, okay. It's as simple as putting this to the root of n. So then it will just be nth root of the absolute value of n minus 2 over 5n plus 1 to the nth power, and since these are both to the nth power, these cancel out very easily. Hey Kevin, wake up, my phone's missing because my brother. This math better be good. My brother in Christ? It's something, alright. It is something. How you doing, Kevin? Wait. Wait, one second. I accidentally forgot we're taking the limit of this. Do you know anything about calculus? Because you're gonna need to know about calculus. So we should be taking the limit of this of n approaches infinity. That's good to hear. Your brother just yanked your phone like, haha, gone, idiot. If he's like young, you should like dangle him over the balcony. But don't do that. Please don't do that. I'm just saying this as a joke. So then this is equal to limit of n approaches infinity of the absolute value of n minus 2 all over 5n plus 1. Very nice. And now from here, we can figure out whether or not it's convergent or not. And... oh yeah, right, just literally divide by n. And from here, all we have to do is divide by... oh. It is divergent. Do you know anything about calculus at all? Like, I had like 4 people come into my stream like, dude, what the fuck are you doing? Like, several different people. One of my friends, 2 of my IRL friends are looking at this like, man, you have to stop. This is enough. Alright, so now, from here we can actually divide everything by n. Like, I do mean, no, doing algebra 1. Oh my god. Oh my fucking god. Yeah, you might think like I'm absolutely insane by writing like everywhere, but no, in college, if you do like take a major that requires like math, like CS or engineering, yeah, you're gonna... oh, and science. I forgot about science. Super fucking important, science. My friend though, he learned calculus in 5th or 6th grade. Oh, I heard about it. Some classes doing now, like pre-calc. Pre-calc is actually much harder than calculus. Like, I'm in Calc 2 right now, and I'm still struggling with pre-calc. Because pre-calc isn't hard necessarily, it just requires memorization. Hi, Ma. I have been told it is not. Am I about to be schooled by the YouTube chat? I am fully prepared, and I think I'm doing this correctly. What the fuck? He looks at the frame data for Smash Brothers? Does he like... wait. Is chat being cut off? What the fuck? What the fuck? Chat was being cut off this entire time? Oh my fucking god! You're actually kidding! No way! Have I just been buffoon? A fool? Oh my god! I cannot believe this! No, you're joking. Wait a minute. Oh my god, it is! Oh no! It's not making a new line! Well, I have a better idea. I'm just gonna turn off chat. Sorry, VOD. You're not... Good luck. Just good fucking luck. He taught... Well, let's go back a second. He taught himself calculus. That's actually insane. How would you... How would you even go about teaching yourself calculus? Because, like, I'm trying to teach myself, like, a fucking, like, brand new language. I'm struggling because, like, the documentation's, like, kind of... It's not shit. It's just, it's Rust. It's just weird. Rust just looks weird. How about that? And I'm actually gonna stop learning Rust. Makes sense. He's currently a band kid. Why are No, my friend, a band kid, came in and just started helping me with my calculus. Again, he didn't, like, solve, like, anything, like, by himself. But he was confirming whether I was right or wrong. Which is kind of funny. And of course, he has a he's majoring in a fucking... He's getting a fucking music degree. I forgot what he's majoring specifically, but it's with music. I know that for a fact. And from this, we can divide... I need to get back on track. I'm sorry. We're dividing everything by n over here. Band kits are built different, simply. And if we divide everything by n, I'm pretty sure we're keeping it in the absolute value for this very moment. So, let's go do the absolute value. So this would be 1 minus 0 minus... Yeah. 5 plus 0. And that's very simply 1 over 5, and that is less than 1. This converges by the root test. Yay! I've done it! ABR can do calculus. Unbelievable. There we go. Converges by root test. Next question. 50. Technically speaking, I'm done with my homework after this. I'm not sure if I'm going to continue streaming, because I've been streaming for like a while. I've been literally streaming for 3 hours just doing my homework. And like talking to myself. You're probably wondering, why on earth would like I subject myself to this? And that's because like the best way to do it is like pretend you're teaching someone. And as long as I can continue to what? Hello, Markman. Welcome to this YouTube stream. But my idea is like as long as I'm what is it? Pretending to like teach someone, it will actually make me a better it'll just make me better at calculus. If you're like confused or like don't understand any of this, then I'm sorry. You don't you just woke up. Why? My man, it is 4 in the afternoon. Why? Ew, calculus. Ew, man. Ew, May. May, you... It's not calculus, it's Calc 2, which is even worse. No, actually, I'm joking. I actually really like calculus. I'm like being serious. I actually really like Calc 2. It's lunchtime! Yay! CSGO got me. Damn, CSGO got him good, boys and girls. Espen chat for the homie. No, I'm not gonna lie. I am pretty hungry. Not starving. Though this might actually be my last problem because I'm looking at it. And unfortunately, Calculus CS on paper. I'm starving. I might have to leave though because my sister is asking for a ride, so I'm just gonna finish up with this problem and see what's happening right now. But if you like what I'm doing or think I'm absolutely fucking insane, please hit that subscribe button because it makes me feel better about myself, knowing that people like me, and that people will continue to allow me to be a fucking psychopath on stream. This is what it's gonna be like when I transfer, by the way. I'm just gonna be doing my calculus over like, oh fuck, oh no, like, hey guys, I need help with calculus, hop on. I forgot, 50, okay, 50. Let me write it down before we forget. 50. After having a Diet Pepsi and switching to Diet Coke, I have mentally prepared my body. I cannot believe you subject yourself to Diet Coke. The Diet Soda, let me rephrase. Diet Soda is probably the worst thing for you. Worse than normal soda. You think all that sugar is bad for you? Have a Diet Pepsi. You'll just get cancer. What the fuck is that? What is that? What is this emote? Oh, by the way, real quick. Let me actually, like, show you guys. One second, where is it? You can actually, get... If you have Better TTV installed, just go to settings and just do emote menu. That's right. ABR Drake's in the chat, everyone. It might not show it on your screen, but it definitely works. I'm telling you right now. Just drink regular soda. How about you eat my ass? How about that, huh? Have you considered that? just being a dick for no reason at all. Am I sorry? No, not at all. Will I continue to be a dick? Yes. I'm losing my viewership. Actually, no, this is the highest concurrent viewers I've had all stream, and I don't give a shit. Unless it's Mountain Dew. I fucking hate soda. Like, actually. That's Alabama. My friends, I had friends who were like cousins with people from like the like actual South, and like the stereotype of like people from the South like munching. I'm talking about like hillbillies, like just munching on like Doritos, and sucking down Mountain Dew is like a real thing. I thought it was just like a dumb stereotype. No, it's like a real fucking thing. Like they wouldn't eat anything if it. They wouldn't touch a snack if it wasn't Doritos, and they wouldn't drink water. They would drink Mountain Dew. Like the most disgusting human beings alive. I'm not like saying everyone in the South is bad. No, that's wrong. But drinking only Mountain Dew, my guy, you need to go to a doctor. Anyway, what was I talking about? Oh yeah, right. Ln of the Lehman sum, my bad. Lehman sum of n approaches infinity equals ln of n over n to the nth power. Prime. I've had Prime once, and the first time I bought Prime, I watched like 6 or 5 children. Yeah, 6 or 5 children like trying to buy up the supply of Prime with literally quarters they're finding off the ground. Like, what's the fucking point? Like, what's the hype around Prime? I had it. Overpriced Gatorade, and it's way too fucking sweet. Like, actually tastes like shit. I'm sorry to say. If you enjoy Prime, good for you. It just tastes like shit. So now we're finding the limit of and approaches infinity. I should probably work on this. I actually do need to like do this. Of the nth root of the absolute value of ln of n over n to the nth power. The n's cancel out, so we can simply just better than G Fuel and Ghost Energy. I don't hate G Fuel. That's about it. I just don't hate G Fuel. I don't think G Fuel's bad. I don't think Ghost is that bad either. But like, listen, like you'll catch me dead if you saw me with a fucking can of G Fuel or Ghost. Because there's just so much caffeine in it. Like, it's a good pre-workout, but like, just get like C4 or something. Like C4 like tastes like shit, but like at least like it's like good for you. Good for you, as in like as long as you're like, you know, exercising or whatever. I prefer the powdered versions of them. If anything, I had like a Ghost protein powder before. It was not that bad, just strange. So then now we got the absolute value of ln of n over n. Okay. Would this equal 0? Because I forgot to write the limit, but yeah, we're still finding the limit. Would this equal 0 because n approaches 0 faster than ln of n? Sorry, infinity faster than ln of n? This is more directed question towards Ma, if they're on here. Ma, please, lend a helping hand. My limited brain capacity is at its final moments, and I'm scared. It's gonna... Well, nope, it doesn't. Have to lose L'Hôpitals. No! No! Okay. I think we can remove the absolute value, but I'm just going to leave it for the sake of it. Define L'Hôpitals rules. We have to find the derivative of the top and bottom. We're not finding the derivative of the fraction itself. So, it's going to be 1 over n over 1. And so now... okay. Use ChatGPT. ChatGPT is a fraud. Also, I did, not like on stream, but like a while ago. And I remember like, it gave me the right equation, but it was completely wrong. Like, it gave me the wrong answer. I didn't write down the answer. I looked at it, it's like, that doesn't seem right. So I did everything. I crunched numbers by myself and I was like, oh, okay. So what I've learned today is that my job is safe for the next 20 years. So I'm not like worried about chat. Oh God. Oh fuck. Oh God. I see. I may need to fix this. I'll fix it later. Don't worry. Oh God. Okay, but now we can confirm that this diverges because it's our harmonic series. So there we go. Yay! Wait a minute. Wait. I was about to say diverges because harmonic series. Wait a fucking second. No, not the root test. Oh no, it's less than 1. Well, okay, actually, the converges. So that equals 0, so converges by root test. Yay! Well, that's it! You have watched me do my math homework. I do have... I said in the beginning of the stream, but literally no one was here. Like, when I say no one was here, I mean... I had -1 viewer somehow. I'm like still like very impressed by it. I have like a worksheet that I can do, but I think I'm gonna do that on my own. But anyway. It doesn't seem too bad. I have been streaming for about 3 hours and 10 minutes. I don't really have much to say. Oh wait, actually. Let me just go to this really beautiful chatting scene. It's fine. It's fine. Did I accidentally exited out. 1 second. Let me I just want to like end with like this very thing. Okay, so this was going on Twitter for a while, and people were adamantly saying that this is in fact 9. I just want to tell everyone who thought this was 9, oops daisy, is absolutely fucking stupid. Okay, no, I'm not saying that. It's just weird to look at. You're probably wondering what if it's not 9, then what's the answer? It's 1. Let me see if I can like start drawing. What's that? Because if it was 9, it would be 6 over 2 times 1 plus 2. But no, instead we have 6 divided by 2 times 1 plus 2. 42. Thank you, Ma. So everyone was just like thinking like, oh, it's a that's what it is. Yeah, of course it's not 6 over 2 times 1 plus 2. No, of course not. Why the fuck would it be this? No. You have to be a complete moron to believe that this is correct. Am I right? Half of Twitter was saying that this was that was wrong. I fucking hate Twitter. I don't know. It's fucking dumb. I absolutely hate Twitter. I'm saying that right now. Twitter is like a sin. Like everything that's wrong was wrong. You don't go to Twitter for like, you know, smart people. You don't like find like intellectual conversations on Twitter. No, you find the worst possible outcome on Twitter. That's what happens. But that is gonna be it for me, everyone. I'm tired. Tired, that's not the word. I don't want to look at fucking math again. And I have to study for another exam that's also tomorrow. Have you guys ever heard of discrete math? If you're doing CS, you will, and you will suffer. It's actually not that bad. My professor just sucks. How is it not 3? Do the review sheet. Oh, okay, D colon head ass. Alright, okay, fine, I'll do the review sheet. Start bullying people who want to see me succeed. Unbelievable. I'll do a couple of problems because I do like actually like want to like relax for a little bit. Oh yeah, no, the problem was it. Play some TF2. Nah. Were you not there when I said like I'm gonna like give up like gaming? Like no, I said this on stream. Yeah, I'm kind of just like not liking playing video games anymore on stream. I'm not sure if it's about me being an adult, but like I feel like it's just about me having so much more to do. It's not fun, and it's hard to commentate playing video games, because at least, like, with math, I can, like, tell you what I'm doing. For like, if I play, like, a video game like Team Fortress 2, I'm like, okay, what the fuck do I do? Just, like, going all over the place, and just start, like, just waving around my gun, like... I should mention, this is a toy gun. I just punched my monitor. Alright, this is, like, lagging a little bit, so I'm gonna move to a different whiteboard. Just give me a second. Alright, there we go. How small is it? Okay, let me zoom in a little bit. That's fine. Alright, so let's see the first problem. Okay, so we're just finding the limit of the sequence, which shouldn't be that hard. So one is ace of n equals was it cosine? Cosine of 2 over n. I'm gonna need a little help with this one because any like trigonometry, I'm not scared of trigonometry, it just looks weird to me. I guess it's the best way I can describe it. So we're finding the limit of the sequence if it exists. So then in this case, the limit would just be n approaches infinity is cosine of 2 over n, and plugged it in, this approaches 0, this goes to 0, so then in that case, that equals 0, because I'm pretty... Cosine of 0 is 0, right? No, 1, my bad. I know I skipped a few steps over here, but let me just explain real quick. So we're just finding the limit of this sequence. This is not a series. This is a sequence, my bad. And the sequence is, what? Cosine of 2 over n. And to find the limit of it is pretty easy, since we know for a fact that anything over infinity will always go to 0. Unless it's 0 over infinity, then we'll have to do L'Hopital's rule. But we don't have to do it here. So in this case, all we have to do is just simply find the limit, and the limit is equal to 1. I think that's easy as that. And now if we do number 2, which I can just squeeze it over here. I'm gonna dip out of the stream because I'm starving. That's fair. Have a good one, dude. Alright, so if I do number 2... I know my 2s and 1s look pretty similar. I should probably fix that, but it's fine. It's fine. I want to say this one's fairly easy as well, because it's going to be ace of 1 equals radical n over 1 plus n square root of n. And from here, we can, again, find the limit is pretty easy. Of n approaches infinity. Because this is, because all I have to do here is just divide by radical n. So we should end up with 1 over 1 radical n, which approaches 0, plus 1. So that equals 1. Yay. Calculus. I'm telling you right now, I probably would have looked at it and like, what the fuck is this? If I didn't do like that 3 hours of practice I just did a moment ago. I'm being like serious, okay? So I'm just gonna move over here. Yeah, doing sections before, sure. So then now this is technically question number 2. So whatever, it's fine. I'm just gonna go with numbers. So 3. Determine if it's convergent or diverges. If it diverges, find the... Sorry, if it converges, find the limit. Pretty simple, I want to say. So ace of n equals ln of n over n. This don't remember. I don't know why I'm forgetting this one specifically, but oh, whoa. It's radical n. ln of radical n over n. I'm pretty sure in this case, the bottom just goes to infinity faster, and it will approach 0 faster, and it will converge at 0, I'm pretty sure. I don't think it diverges. We can just find the limit of it, and I think we'll probably have like a better idea if it converges, diverges from that. So to do that, will just be the limit of n approaches infinity of ln of radical n over n. And I want to say it... Does it converge? Well, let me see if the all-knowing give me an answer. It's because all I need to know if it converges or not. Oh, it is convergent. Okay. I wasn't crazy for thinking that. That's nice. So then, since... yeah, from here we can just say that it just approaches... The limit will have to be 0 because n approaches infinity faster. Then, yeah. Okay. I think I'm doing good. Am I doing good? I have no fucking clue. And so this is going to be ace of n equals n plus 1 factorial all over n factorial. I want to say this is pretty easy because all I have to do is just very simply rewrite it as what is it? N plus 1. Also, I should probably say it converges at 0. Does not go infinitive. It does not go infinitely. Find the limit of that is equal to n approaches infinity. And we can simply write it as n plus 1 times n factorial all over n factorial. So that goes away. And you're left with n plus 1. Oh, never mind. I'm simply wrong. This diverges. Because if you find the limit of n, it will just go infinitely. If you add a plus any constant to it, it will still go infinitely. Nothing changes. So from there, infinite. I want to say it's pretty simple. So this converges, this diverges. Pretty simple to start off with, at least. Okay, so let's do 5. Oh shit. Okay, this is a bit hard for me. I have to find monoticity and the boundedness of a sequence. Monoticity, there we go. So ace of n equals 4 plus 1 to the e nth power. Are we finding the, I'm trying to figure out if we're using the, what? Finding the integral for it. Integral. Because if we were to find an integral for it, it wouldn't be a weird number. It'd just be a number. I don't know. So, because if we were to find the limit of it, it'd actually just go to 4. And I'm not sure if that's what it's asking. This is a bit weird. So if I were to find a limit, no need for integral. Okay. Because I'm just thinking, like, if I'm just because like if I can just find the limit for this and I just know where it ends. It ends at 4. It converges at 4. N equals n not equals n approaches infinity. And so then it'll be 4 plus 1 over e to the n, and that equals 4. Why? So the bounds I want to say are pretty simple. It ends at 4. It can go no higher. Sorry, higher, is that the word I want to use? Maybe. Oh, this is a. That's a weird question, just as it is. Okay. So now we have 6. I want to right here. Sorry if I brushed the mic. My bad. So be the Lehman sum. Also, I'm not sure how bad the delay is. So if you answer something and I'm like 5 minutes away, I'm sorry. There's not much I can do with YouTube. So infinity to, so n equals 0 to infinity. It's gonna be 4 over 2n. Determine divergence or convergence of the series. So I think a simple way of doing this one specifically, because this is gonna be a geometric series, just by looking at it. And if you're wondering how, then I'll explain it. If we were to find no, not even find the limit of it, we could simply just write this as. Let me make the equal sign. N approaches 0, infinite, as 4 times 1 over 2 to the nth power. What I don't remember is if r needs to be less than. Let's see. R in fact does have to be less than. There we go. Okay. So in this very specific case, by geometric series, we can determine that this r is in fact, this is our r, is less than 1. I'll just set up as this, so r equals 1 over 2, and that is less than 1, and that it converges by geometric series. There we go. Okay. On to the next two. I want to say that one was pretty easy. This one might also be pretty easy. Let's see. So it's gonna be what did I have it as? A 6? Alright, 7. So it's gonna be the there we go. N equals 0 to infinity. N plus 1 over 2n plus. Oh, sorry, not plus, minus 1. With this case, with this one, I think we can just use the what? I'm forgetting the name of it. I know what it is. The test of divergence. There we go. My bad. So the test of divergence, we're just using the limit. That approaches infinity. and dividing all of these by 1. I'm just going to skip the step of rewriting it because it's right there. So it's going to be 1 plus 1 over n, 2 minus 1 over n. I haven't learned calculus yet. I don't know what's going on. We're determining whether the this series is whether it's a divergent or a convergent. It's not easy. I'm saying it's easy, but first time learning it, nah. Yeah, good luck. Hello, Garm. Yeah, you messaged me a while ago. What's up? How is it hanging? Second 1 cent. So doing pretty good. I'm doing all right. I have 2 exams tomorrow. One of them's kind of bullshit though, but so I'm like not too worried about that. I'm worried about this calc exam. Also, my friend just sent me a message with the. That's my thumbnail. Doing calculus. We'll see. Yeah, I'm doing all right. I feel pretty confident with this now. I'm not gonna say I'm 100%, but as long as I practice like some trigonometry and proper integrals, I think it'll be fun. But from here, we can easily determine that this is 1 over 2, and it is not equal to 0. So that means diverges by test of divergence. Usually, for instance, like I can use games for instance. If you're making a game, it relies heavily on calculus. A lot of it's based off physics and calculus, because like in terms of how well the gravity meshes, how well how fast the character goes, especially in like 3D planes. Calculus is everywhere, and we don't even know it. If you're going to engineering, you're going to need to learn calculus. If you're going to any science, you're going to need to learn calculus. Everything in this world requires some sort of calculus, especially in scientific fields, or unless you're a business major. And yeah, if you're a business major, you can go fuck yourself. No, I'm joking. Even art majors need to have some requirement of calculus. Nothing like major, like someone in CS like I. It would just be some like basic stuff, because you actually do need to learn like calculus. Anyway, so from here it's diverges by test of divergence. I don't know, cool kid. Do you have any plans of what you want to do later in life? Ah, okay. I had a whole spiel about ChatGPT. I actually plugged in a question to ChatGPT, and it gave me the wrong answer. Like, it was completely wrong. It told me how to do it, but it did everything wrong. It gave me the right equation, but gave me the wrong answer. God bless ChatGPT. Now I know for a fact I'm gonna have 20 years in this field. Anyway. This is gonna be even sum of n of 0, n of 1. Okay, so n equals 1 to infinity 4 over n times n plus 4. We can use a test of divergence for this one again, just to see if it works. That would just involve us find the limit of approaches infinity and 4 over n squared plus 4n, and we'll end up with, if we find a limit, sorry, if we divide everything by n squared this time, I can already tell you what we're gonna get. And that's going to be 0. And that's going to immediately be 0. Because if we were to divide everything, it'd just be 4 over n squared over 1 plus 4n, and that's simply just saying 0. So this test is inconclusive. We have to move on. What can we do now, you might ask? Well, let's look at what we have for our test. We can do something like we could probably do not a geometric series, no, not a root. Maybe we can do a ratio test, maybe, depending if it's like easy or not. We could do a direct comparison. I think that'll be a little bit harder because my notes on direct comparison kind of suck. And limit comparison, I definitely need to. I always want to do program game as like a side. I always wanted to either, I think you're a therapist or something. Wow, those are very two different fields. Both are not bad by any means. If you do plan on doing engineering, all the math that I'm doing right now will technically be like a fucking cakewalk, because what you have to do for engineering is insane. I'm not trying to deter you from being an engineer. It's just hard to get there. But I respect everyone who does it, because it is a leap of fucking faith. I was like on the same field like when I was a kid, like I liked therapy because I enjoyed helping people, but I realized that it's not that I enjoyed helping people, I liked entertaining people. And so that dream kind of fell through for me. I'm not sure if you're gonna have that revelation, or if you're just gonna stick with it. If you're very passionate about it, by all means, stick with it. Anyway, one second, let me just figure this out. So I guess I could just do it's not alternating series. I could do the ratio test, because I think it'll be pretty easy. I'm being called. This might be it for me, fellas. Sorry, just give me 1 second. Alright, I'm back. Sorry about that. I'm just gonna finish up with this problem, then I'm gonna head off out. Oh, of course! No, I'm just saying, like, I was around the same age when I had that, like... I didn't have that revelation at that age. I'm just saying, like, when you come closer to an adult, you'll just like, oh, okay, this is what I want to do. Or you can be like me. I was completely lost for my first 2 years of life. Of college. I literally didn't know what the fuck I wanted to do. I was absolutely petrified, and it's okay. It is entirely okay, and I don't think people like hear that enough. I definitely didn't hear it. I definitely did not hear it. I felt like an absolute disappointment. But it is okay to be lost. And as long as you like understand that it's okay, then you can get through anything. I hated programming when I first started, and now I've fallen in love with it. Like, I've fallen completely in love with it. So you never know what you're gonna, do when you're in college. Just like, if you're really passionate about something, then stick with it. Even if it's a hobby, or if you don't like see it as like a future endeavor like this. I've been streaming for like almost 5 years now. I'm not like planning on like making it big. I'm just doing this because I think it's fun. No other reason. Hey, you never know. If you, Python's probably the easiest language to learn, even though I'm not a big fan of Python. I would probably say it's, like, definitely the easiest one to learn and, like, probably to make a game with. Alright, so let me actually do this real quick. So, what I can do is, I guess, I can just do the I think the ratio tests we better think. I'm not sure. You're learning C sharp. I'm about to like teach myself C sharp because you remember May? I mean, we probably ran into each other on the stream once, but yeah. He's like an actual programmer, and he fucking loves this shit more than me. And we're like having an idea of making a game with Unity, so we can like use either the plugin for Unity for ChatGPT for OpenAI, or the one for C sharp, and just directly do our programming with C sharp, and then just plug it into Unity. We're gonna figure everything out first, because we're both in college, and we're trying to like, you know, get through the semester before we even do anything serious. I think it'd be cool. There are many tutorials online, so like you will not struggle learning a language, like at all. Would a ratio test be better? I mean, I could just do. I could just do a direct comparison, I think. Would that work? Yeah, because all I have to do is just n squared, and then it'll just be, what's it called? Let's just make our b sub n here. N equals 1. So then it'll just be 4 over n squared. That'll be our b sub n. And find the limit of this is very easy, because that already goes to 0. I'm pretty sure that is okay. Oh no, it's weird. It's definitely weird, and it's being held back a lot. But that makes sense, because if we allowed AI just to say whatever it wants, then we will just be going backwards. We'll actually be destroying technology. I'm like confident in that. So, by this definition, this is actually greater than our original even sum. So then from here, we can just, what are we supposed to do? Let me look at my notes just to make sure I'm not like, oh wait, comparison. Yeah, and from here, now we can just, now we can see if it converges or not. And I guess we can just do a very simple, oh, P series, yeah. So, P is equal to 2, and that's greater than 1. So, very simply, this converges. That's a very weird W, doesn't matter. So now this one converges by P's. Converges by P series. And now this one, it's gonna right over here, is by direct comparison. There we go. I think I spelled comparison wrong, but I'm a CS major, non-English major. I don't give a fuck. Anyway. That is gonna be it for me, because I have like a bunch of shit to do. I know my chat's a bit messed up. I'm gonna fix that in a second. I didn't even know it was like that this entire stream, so I was like, whatever. I'll be fine. But fuck. Okay. Anyway, is that 07? 07, beautiful. But yeah, I've been doing this for what, 4 hours? Oh my god, I've been doing this for almost 4 hours now. My god, dude. My god. Thank you all for watching. I've definitely gotten a lot better because I was able to speak out about what I wanted to do. And actually, like, you're gonna see more streams of this. Whether it's boring or not, I'm gonna continue to do it because, like, it helps me so much. Anyway, I'm gonna catch you all in the next one. Adios, gamers.